Now we'll start with the next one, which is called as factorization. The next method that we'll start with is called as factorization. Now here, let's see how do we do this. Limit of x tends to root 2 x square plus 3 root 2 x minus 8 upon x square minus 2. Whenever you have a square root sign in your quadratic, or if you have the degree of the polynomial is greater than 2, that means you have 3 or more than 3 in your indice, then you generally solve this by using synthetic division. It's easier to solve this by using synthetic division. How do I do synthetic division? First thing that you do is you write the coefficients of the variables, that means the numbers which are there. I am synthetically dividing the numerator, so 1, 3 root 2 and minus 8. Write the limit whatever x tends to as the other term. Okay. Now bring the first number down here as it is. Now 1 into root 2 is root 2. 3 root 2 plus root 2 is 4 root 2. 4 root 2 into root 2 is 8. Remainder comes to 0. If the remainder comes to 0, that means your synthetic division is correct. How do I get the factors? I could say therefore x square plus 3 root 2x minus 8 factors are, one of the factor will be this term with opposite sign, complementary sign. So that means this is plus root 2, therefore one of the factor will be x minus root 2. This will take the variable x raised to 0, x raised to 1. So x plus 4 root 2. So these are going to be my factors of the numerator. Now let's start with the sum. Limit of x tends to root 2. Instead of numerator, I can write this x minus root 2, x plus 4 root 2. In the denominator, x square minus 2. 2 can be written as root 2 the whole square. This can be written as limit of x tends to 2, x minus root 2, x plus 4 root 2 upon, this is in the form a square minus b square. So this will be a plus b, a minus b. Cancel, cancel. Once you cancel in the numerator denominator, you can substitute. So this is going to be root 2 plus 4 root 2 upon root 2 plus root 2. This is 5 root 2 upon 2 root 2, which is nothing but 5 upon 2. Right? Let's see another sum of this kind, guys. Limit of x tends to half, 2x cube plus x square plus x minus 1 upon 4x square minus plus 8x minus 5. Now, since the degree of polynomial is greater than 2, therefore I will solve this by using synthetic division. Synthetic division. Division. First thing I need to do is write the coefficients. 2, 1, 1 and minus 1. 2, 1, 1 and minus 1. Write the value of x here. X tends to half, you write half here. Now, bring the 2 down here as it is. 2 into half is 1. 1 plus 1, 2. 2 into half is 1. 1 plus 1 is 2. 2 into half is 1. Plus 1 minus 1, 0. Since the remainder comes out to be 0, that means my synthetic division is correct. Now, what are the factors going to be? I could say that therefore 2x cube plus x square plus x minus 1 this number with opposite sign. So x minus half, x raised to 0, x raised to 1, x raised to 2. So this is 2x square plus 2x plus 2. LCM 2x minus 1 upon 2. Here I will take 2 common in the numerator. So 2x square plus x plus 1. 2 and 2 gets cancelled. 2x minus 1, x square plus x plus 1. Now let's start with the sum. Limit of x tends to half. This term, the numerator, we found out the factors to be this. This is 2x square minus 2x minus 1, x square plus x plus 1 upon. In the denominator, now this term could be written as, I could factorize this 4x square, 8 5s are 40, 10 4s are, no, 6, 4 5s are 20 and 10 2s are, so plus 10x minus 2x minus 5. Now this can be written as limit of x tends to half, 2x minus 1, x square plus x plus 1 upon. Between these two terms I could take 2x common. So in that case I will get 2x plus 1, 2x, no, this is going to be 4x and this is 2x plus 5 minus 1, 2x plus 5. This is going to be limit of x tends to half, 2x minus 1, x square plus x plus 1 upon 2x minus 1, 2x plus 5. 2x minus 1 in the numerator and denominator gets cancelled. Once you cancel, then you can solve this way. Substitute the value. So in that case, this is 1 upon 4 plus 1 upon 2 plus 1 upon 2 into 1 upon 2 plus 5. 4 is the common denominator. 1 plus 2 plus 4. Cancel. 6, 4, 6, 7. 7 upon 6 4s are 24. So the answer is going to be 7 upon 24. Fine. Let's move on ahead. Now, this was how you would solve by synthetic division. Now, we also have a formula wherein you could solve all this. Let's see the formula. Let's write the formula in some other color. The first formula of limits. Limit of x tends to a, x raised to n minus a raised to n upon x minus a is n a raised to n minus 1. When you have variables greater than 3, which generally are solved by using binomial, instead of using binomial, what we do is we solve this by using the formula. Fine, do we get this thing clear? Now, let's see this. Suppose if I had a sum like this. Limit of x tends to a, x raised to 4 minus a raised to 4 upon x cube minus a cube. Let's see this. Now, the first thing that you need to do is you need to have the same term in the denominator that you have in the numerator without the indice. For this, I'm going to divide the numerator and denominator by x minus a. So if I divide the numerator and denominator by x minus a, this is x raised to 4 minus a raised to 4. Guys, look at this. X raised to 3 minus a raised to 3. I divide the numerator by x minus a. I divide the denominator by x minus a. Now, my numerator and denominator both are in the format of the formula. I can use the formula both in the numerator as well as the denominator. Now, this is a raised to n. So, this is going to be numerator. n, this is n, this is a, n a raised to n minus 1. Similarly, in the denominator, n a raised to n minus 1. So this is going to be 4a cube 3a square, 4 upon 3a. That's going to be the answer for that. Let's see another sum, guys. Limit of x tends to 2, x raised to minus 3 minus 2 raised to minus 3 upon x raised to minus 2 minus 2 raised to minus 2. Now, same thing, divide numerator and denominator by x minus 2. This is limit of x tends to 2, x raised to minus 3 minus 2 raised to minus 3, x raised to minus 2 minus 2 raised to minus 2. Divide the numerator by x minus 2, divide the denominator by x minus 2. Right? Simple, straightforward sum. You will get your answer. This is n. The indice is n. n a raised to n minus 1. Similarly, in the denominator, n a raised to n minus 1. Minus sign gets cancelled. This is 3 upon 2 as it is. This is 2 raised to minus 4 upon 2 raised to minus 3. This is nothing but 3 upon 2 into 2 raised to minus 4 plus 3. 3 upon 2, 2 raised to minus 1. So answer is 3 upon 4. Once you have the formula, the sum becomes relatively easy. Right? Now let's see another sum of this kind. Limit of x tends to 3, x raised to 5 minus 243 upon x cube minus 27. Right? Now, this can be written as limit of x tends to 3, x raised to 5, 243 can be written as 3 raised to 5, x cube minus 27 can be written as 3 cube. Then the same thing that you did in the previous sum, divide the numerator denominator by the same term without the indice. So in which case this will be limit of x tends to 3, x raised to 5 minus 3 raised to 5 upon x cube minus 3 cube. This is x minus 3, x minus 3. I am dividing the numerator and denominator by x minus 3. Right? Use the same formula that's written up there. So this is going to be equal to, here n is 5. n a raised to n minus 1 upon n a raised to n minus 1. This is 5 upon 3, 3 raised to 4 upon 3 square, 5 upon 3, 3 square, 3 and square gets cancelled, answer is 50. Let's see another sum, guys. Now, limit of x tends to minus 2, x raised to 7 plus 128 upon x raised to 5 minus 32 plus 32. Okay. Let's see the sum. Now, it's going to be very simple, straightforward sum. But the problem is, my formula has a minus sign whereas this has a plus sign. So the first thing I need to do is, I need to convert this into a minus sign. This can be written as limit of x tends to minus 2, x raised to 7 plus 128 can be written as minus of minus 128. Similarly, 32 can be written, plus 32 can be written as minus of minus 32. This can be written as limit of x tends to minus 2, x raised to 7 minus 128 can be written as minus 2 raised to 7. Similarly, minus 32 can be written as minus 2 raised to 5. Same thing, divide the numerator denominator by the same number. So this is limit of x tends to minus 2, x raised to 7 minus minus 2 raised to 7 upon x raised to 5 minus minus 2 raised to 5. Divide the numerator by x minus minus 2. Divide the denominator by x minus minus 2. You are dividing the numerator and denominator by the same term. Now, the same logic again, n is 7 here, n, a, n minus 1. Similarly, in the denominator, n, a, n minus 1. Now, this can be written as 7 minus 2 raised to 6 upon 5 minus 2 raised to 4. 7 upon 5 minus 2 raised to 2, which is nothing but 4. So 7 into 4 upon 5, answer is 28 upon 5. Fine. Let's move on to another sum, guys. Limit of x tends to a, x raised to 1 by 3 minus a raised to 1 by 3 upon x minus a. Straightforward sum they've given you. They've given it to you as 1 by 3, so this is n a raised to n minus 1. 1 by 3 a raised to, this is going to be 1 minus 3, so minus 2 by 3. Right? Next, let's see another sum. Suppose if I have fractional indices both in the numerator and denominator. X raised to 3 by 5 minus 2 raised to 3 by 5 upon x raised to 2 by 5 minus 2 raised to 2 by 5. Same thing, divide the numerator denominator by the same term. So limit of x tends to 2, x raised to 3 by 5 minus 2 raised to 3 by 5 upon x raised to 2 by 5 minus 2 raised to 2 by 5. Divide the numerator by x minus 2, divide the denominator by x minus 2. Right? Now this can be written as n a raised to n minus 1. Similarly, in the denominator, n a raised to n minus 1. 5 and 5 gets cancelled. This is 3 upon 2. 2 raised to 3 minus 5 minus 2 upon 5. 2 minus 5 minus 3 upon 5. This is 3 upon 2. 2 raised to minus 2 by 5 plus 3 by 5. Law of indices. A raised to m upon a raised to n is a raised to m minus n. 3 upon 2 into 2 raised to 1 by 5. That will be your answer. Let's see the last sum of this type, guys. Limit of x tends to 1, x plus x square plus x cube plus x raised to n minus n upon x minus 1. Now before we start with the sum, let's try to understand the logic. Minus 3 can be written as minus 1 3 times. Minus 4 can be written as minus 1 4 times. Similarly, minus n can be written as minus 1 n times. So what I am going to do is I am going to split this minus n as minus 1 n times. Since there are n number of x terms, therefore each x term is going to take a 1. See how this works out. This is limit of x tends to 1, x plus x square plus x cube plus x raised to n. Minus n I am splitting as minus 1 n times upon x minus 1. Split the numerator. Limit of x tends to 1, x minus 1 upon x minus 1, x square minus 1 upon x minus 1, x cube minus 1 upon x minus 1, x raised to n minus 1 upon x minus 1. Right? This cancels 1. 1 can be written as 1 square. Whether I write 1 or I write 1 square should not make a difference. So this is going to be n a n minus 1 formula, x raised to n minus a raised to n upon x minus a. Similarly, 1 can be written as 1 cube, same formula again, n a raised to n minus 1. 1 can be written as 1 raised to n, same formula again, n a raised to n minus 1. Now 1 raised to anything is 1 and multiplied by the given number should give you the number. That means this will be 1 plus 2 plus 3 plus n. But this is the sum of first n natural numbers. 11th standard. Sum of first n natural numbers is n plus 1 by 2. So your answer will be n plus 1 by 2. Right? This finishes this topic of formula. Next time we start with trigo. Let's stop here for the day, people.